What if every single choice you've ever made, every hesitation, every whispered yes, every silent no, has not disappeared into the past, but exists somewhere else? What if there is a version of you who turned left instead of right, who stayed instead of leaving, who spoke instead of staying silent? A version who became something entirely different, not in a dream, not in imagination, but in a world as real as the one beneath your feet, right? Our understanding of reality has always been shaped by what we can touch, what we can see, what we can measure. For centuries we've believed in a single thread of existence, a linear story, unfolding moment by moment, where one event follows the next. But what if that thread is not alone? What if it is just one of countless invisible filaments, woven into a vast cosmic tapestry that extends beyond the reach of our perception? We walk through our lives anchored to the assumption of one universe, one reality. But modern physics, the strange, counterintuitive language of the quantum realm, whispers something far more radical. It suggests that reality itself may not be singular, but multiple, layered, infinite. It suggests that what we know is only a sliver, a single room in a house with endless corridors and unopened doors. In the smallest spaces imaginable, in the quiet theater where particles dance and vanish and reappear, something extraordinary is happening. Reality does not behave as we expect it to. It branches. It splits. It superposes. It is as if the universe itself is writing not one story, but an infinite library of possibilities, each page turning silently, all at once. We tend to think of parallel dimensions as the stuff of science fiction, a place where heroes cross portals, timelines collide, and alternate versions of history unfold in dramatic fashion. But beneath the spectacle of fiction lies a real and unsettling question that physicists have been asking for decades. Is our universe truly alone? At the heart of this mystery lies quantum mechanics, a branch of physics so precise, so successful in describing nature, that it underpins everything from computers to nuclear energy to the stars themselves. Yet its implications for reality are so bizarre, so unsettling, that even its greatest pioneers were left bewildered by their own discoveries. Imagine a coin spinning through the air. In our everyday world, it must land on heads or tails. But in the quantum world, before it lands, it is both. Every possibility exists simultaneously, overlapping, dancing in a superposition that defies common sense. And when the coin is finally observed, it chooses. But what if it doesn't choose at all? What if both outcomes happen, each in its own separate universe? We live at the surface of a deeper structure, a structure in which every event, every quantum flicker, may be weaving entire new branches of existence. Reality may not be a straight line. It may be a vast tree constantly growing, splitting, multiplying in silence. But how could that be? How can something so unimaginable be rooted in the very mathematics that describes our world with exquisite accuracy? To understand, we must first challenge the bedrock of how we perceive reality itself. We must let go of the comfort of certainty. We must step away from the narrow hallway of one universe and into the endless halls of many. Throughout human history, we have sought to answer questions about our place in the cosmos. We once believed Earth was the center of everything. Then we learned it wasn't. We believed the stars were fixed, immutable. We discovered there were countless suns. We believed the universe had limits. But now science whispers something even more staggering. There may be not just one universe, but many. And if that is true, then our existence is not singular. It is part of something unimaginably vast. Our journey begins here, at the boundary between the known and the unthinkable. At the place where reality, once considered stable and singular, fractures into an infinite lattice of possibility. We will travel through the ideas that have shaken modern physics to its core. We will listen to the strange language of particles that refuse to follow ordinary rules. We will stand at the edge of mathematical landscapes that hint at other worlds. We will ask questions that may have no answers, not yet. What if every moment of your life exists, side by side, in infinite mirrors? What if every decision, no matter how small, carves new universes into being? What if the reality we know is just a single note in an infinite cosmic symphony? This is not a tale of fantasy. This is a journey through real science, complex, daring, and unfinished. We will explore the origins of the many worlds interpretation, the strange behavior of quantum systems, the elegant mathematics of string theory, the whispers of the cosmic microwave background, and the philosophical riddles that lie beneath them. We will explore not only the universe we inhabit, but the infinite universes that may lie beyond. Reality is not what it seems, and the further we peer into its fabric, the more it unravels. The more it reveals a landscape where possibility and existence are intertwined in ways our minds can barely grasp. Tonight, we step into that landscape, not as dreamers, not as storytellers, but as explorers of the possible. This is the story of parallel dimensions. This is the story of the quantum multiverse. And perhaps it is the story of us reflected endlessly across a reality we have only begun to glimpse. Chapter 1. Beyond Our Universe. What if everything you know about existence is just one tiny fragment of a much larger truth? We move through our days believing that reality is simple, that there is one timeline, one version of events, one world where everything unfolds. We wake, we breathe, we make choices, and those choices shape the single path we call our life. But deep beneath this surface simplicity, hidden in the equations of physics and the strange logic of the quantum realm, lies a whisper that reality may not be one, but many. That our universe may be just one drop in an infinite ocean. For centuries, our ancestors looked to the heavens for meaning. They saw a sky full of stars and thought they were watching eternity itself. Every light in the night seemed to affirm that there was one universe, vast and mysterious, but singular, a grand stage upon which everything plays out. But even as telescopes reached farther, even as cosmology painted grander pictures of the cosmos, something unexpected began to emerge from the smallest realms of reality. While astronomers searched outward, physicists searched inward, and what they found defied all reason. At the atomic scale, the world no longer behaves like a predictable clockwork machine. Particles appear and vanish. They exist in two places at once. They tunnel through barriers that should be impenetrable. They seem to know when they are being observed. And this behavior, though bizarre, is not speculation. It has been tested, measured, and confirmed countless times. It is not just strange, it is real. and it is the foundation of everything. Imagine standing at the edge of a mirror that stretches forever. Each reflection shows a slightly different version of you, a face turned a little differently, a hand lifted or lowered, a thought delayed or spoken. Now imagine that each reflection is not a reflection at all, but a real physical world, complete, solid, and existing simultaneously. That is one way to imagine what the idea of parallel universes implies. But before we reach that vision, we must begin with what we once believed. For thousands of years, reality was considered absolute. The Greeks spoke of a cosmos governed by harmony and order. Newton described a universe of absolute space and time, predictable, mechanical, unchanging. In his world, the universe was like a grand clock, wound at the beginning and ticking ever onward, obeying precise and universal laws. There was no room for ambiguity, no place for uncertainty, no branches, no alternate paths, only one unfolding story. Yet even Newton's elegant clock could not hold against the discoveries that would come. At the dawn of the 20th century, the universe cracked open. Relativity reshaped our understanding of space and time, bending them into a cosmic fabric that could twist and warp. But deeper still, quantum mechanics emerged, and it shattered everything we thought we knew. The quantum world does not obey classical intuition. It does not exist in fixed positions or definite states until we look. It behaves like waves of probability, a ghostly haze of potential outcomes that only solidify when measured. And if that is true, then what happens to the other outcomes? If a particle could have gone left or right, and we observe it go left, what becomes of the right? Does it vanish into nothingness, or does it continue elsewhere? Physicists began to realize that perhaps the universe does not choose one path. Perhaps it takes all of them. Every possible history, every possible outcome, every quantum event, all realized, all existing, side by side. Not as fantasies, but as realities. Each one as real as the world you are in right now. To grasp how revolutionary this is, imagine tossing a stone into a still pond. The ripples spread outward in perfect circles, simple, predictable. That is the universe as we once believed it to be. Now imagine instead that each ripple splits into more ripples, each one representing a new version of the pond, each one diverging ever so slightly. And those ripples themselves split again, endlessly, creating not one pond, but a boundless network of possible ponds, each with its own pattern of waves. That is the image of a multiverse, a reality that multiplies with every quantum decision. But before the quantum world was discovered, humanity believed in boundaries. The universe had an edge, once thought to be the sky, later the stars, then the reach of galaxies. Each new discovery expanded our map of existence, but still we assumed it was one singular whole. It took centuries for us to realize that even this may not be true, that the universe might be plural. When we look out into the cosmos today, we see a universe roughly 93 billion light-years across. We see galaxies, clusters, cosmic filaments stretching like veins across the dark. But what if all of this, everything we can observe, is only one small pocket of a grander structure? What if beyond the cosmic horizon lies another bubble, and another, and another? each one expanding, each one with its own stars, its own laws, its own story. Some physicists call it the cosmic landscape, others the multiverse, a boundless space filled with self-contained universes, each possibly with different constants, different histories, different versions of reality. The multiverse is not yet proven, but its possibility arises naturally from mathematics that already describe our world with uncanny accuracy. But to truly sense its meaning, we must return to the human perspective, to what it feels like to live inside one version of reality, while others might be unfolding just beyond reach. Because if the multiverse exists, then everything, every moment of love, every tragedy, every possibility plays out somewhere. There is a universe where ancient civilizations never fell. A universe where Earth circles a different sun. A universe where you are listening to this same voice, but your life took a different turn long ago. An infinite library of histories, all written, all real. This idea may feel unsettling. It may even feel meaningless, as if our choices lose their weight in the face of infinite repetition. But perhaps it means the opposite. Perhaps each decision, no matter how small, carries infinite echoes, each one giving rise to new realities. Perhaps every choice is a creative act, birthing entire worlds from the fabric of quantum possibility. And so we return to the question, what if everything you know about reality is just one tiny piece of a far greater puzzle? A puzzle that includes not just our universe, but an unending sea of others, each born from the quantum storms at the foundation of existence. We are, perhaps like shadows cast by a higher dimension, unaware of the light that makes us. Each life a strand in a web of infinite possibilities, all woven together, unseen, yet deeply connected. In this chapter we glimpse the threshold, the realization that the universe we see might not be the whole, but a part, a single drop in an endless rain of worlds. And if that is true, then what lies beyond this one we call home? What mechanisms could bridge the gap between our world and the unseen ones that may surround it? To find the answer, we must go smaller, down into the quantum abyss, where particles flicker between existence and possibility, where the laws of logic begin to dissolve, and where the foundations of reality are rewritten. For beyond our universe lies not emptiness, but infinite versions of everything. And in the next chapter, we will step into that strange realm, where the quantum world itself becomes the gateway to all others. Chapter 2. The Quantum Leap to Other Worlds. At the heart of every mystery lies something small, almost invisible. And in the case of reality itself, that something is the quantum world, a realm so strange that it seems to defy everything we know about existence. Down there, beyond the limits of our senses, particles do not act like tiny billiard balls bouncing predictably in space. They shimmer, they overlap, they exist in superpositions of being and not being until something happens, until they are measured, until they are seen. Only then do they seem to choose. But what if the universe never forces them to choose at all? What if every possibility that could happen does happen each in its own separate world? This is where our story takes its next leap into the foundations of the many worlds interpretation. To understand it, imagine a single electron. It has no size that we can truly picture. It moves like a wave, spreading through space, existing everywhere it could possibly be. When we try to observe it, to pin it down, to make it real, it suddenly behaves as if it had only one position all along. But before that observation, the mathematics tells us that it was not at one place. It was at all possible places, simultaneously. It is a ghost of probabilities, a chorus of overlapping possibilities. This is called superposition, one of the most baffling ideas in all of science. To our minds, it makes no sense. A coin cannot be both heads and tails. A door cannot be both open and closed. Yet at the quantum level, nature does exactly that. Reality holds both options in suspension, waiting. When the physicist Erwin Schrödinger wanted to show just how absurd this was, he imagined a thought experiment. A sealed box. Inside, a cat. A small vial of poison. And a single radioactive atom that has a 50% chance to decay in 1 hour. If the atom decays, the vial breaks and the cat dies. If not, the cat lives. According to quantum theory, until the box is opened and observed, the atom is both decayed and undecayed. And thus, so is the cat, both alive and dead. This, of course, is impossible, or so it seems. But what if the universe does not collapse to one outcome when the box is opened? What if instead the act of observation divides reality into two? In one world, the atom decayed, and the cat is dead. In another, it did not, and the cat lives. Two worlds, both real. Two outcomes, both true. And the observer, too, splits into one who sees a living cat and one who sees a dead one. This is the essence of the many worlds interpretation, first proposed by physicist Hugh Everett III in 1957. At first his idea was dismissed, too extravagant, too strange, too vast. But Everett saw something elegant in its logic. He believed that quantum mechanics should be taken literally, that every quantum event creates a branching of reality, not through magic, not through consciousness, but through the natural evolution of the wave function, the mathematical description of everything that exists. The wave function never collapses. It simply unfolds infinitely into all possible outcomes. Each possibility exists, not as potential, but as actual. Every roll of every quantum dice is realized somewhere. In Everett's vision, the universe is not a single story, but a boundless branching tree, an ever-growing network of realities that diverge at every quantum event. Every time an atom decays or doesn't, every time a photon travels left or right, the universe divides. And in this vast cosmic garden of forking paths, every choice you make and every choice you don't plays out in some version of reality. To most physicists of his time, this idea seemed unnecessary. Why multiply worlds when one will do? But Everett countered. Why should we assume the universe deletes information? Why should we believe that only one outcome is privileged, when the mathematics of quantum theory allows all of them? The truth is, the equations of quantum mechanics have no special rule that says only one outcome becomes real. The idea of collapse, the moment when possibilities narrow to one, was something we invented to make the equations fit our common sense. But nature may not care about our common sense. In the quantum world, there is no final choice, no single thread of fate. There is only branching, endless, ceaseless branching. To grasp this, imagine time not as a line, but as a living organism. It grows. It splits. It divides into infinite twigs of possibility, each one continuing forward, unaware of the others. Every time a quantum decision is made, every time a particle takes one path or another, reality itself divides, duplicating every observer, every atom, every moment. Each version feels as real, as solid, as certain as the next. And yet, they are all part of one greater whole. This is the quantum leap to other worlds, not through portals or wormholes, but through the natural unfolding of existence itself. You don't travel to other realities. You generate them simply by being. When you decide to take a step or to stay still, when a photon reflects or transmits, when a neuron in your brain fires this way instead of that, the entire universe splits around you, carrying forward both versions of what infinite realities born from the tiniest flickers of chance. In one, you look up. In another, you look away. In one, you speak. In another, you remain silent. In each, you are as real as you are here, but your path is different. And each difference, no matter how small, grows into its own unique universe. This idea sounds impossible, almost poetic, and yet it is mathematically consistent with everything we know about quantum mechanics. Everett's theory does not add new rules. It removes one, the arbitrary collapse of the wave function. It allows the universe to be what the equations already describe, a vast superposition of all possible states. But if there are infinite versions of you, what does that mean for identity, for consciousness, for free will? If every possible decision is realized, are you really choosing, or are you simply following one branch among many? These are questions physics alone cannot answer, and yet they haunt the edges of this idea, because the many worlds interpretation does not just describe a physical process. It redefines what it means to exist. Imagine standing at a crossroads where every direction you could take is real. You turn right, but somewhere another you turns left. You stop, but elsewhere another you runs forward. Each choice a world. Each decision a birth of universes. The totality of all these possibilities, that is the multiverse. In one branch the earth never formed. In another it did, but life never arose. In yet another, civilizations flourished long before ours. The laws of physics may be slightly different in some. The constants of nature may vary just enough to change everything. And yet all of it exists within the same grand quantum fabric. The strange thing is, we cannot step between these worlds. The branching is clean, total, and irreversible. Once they diverge, they no longer interact, like echoes fading into silence, each carrying its own version of the song. We are confined to our branch, blind to the rest. But mathematically they are there, silent, invisible, yet just as real. To some, this vision is thrilling. A universe teeming with infinite variation, infinite life, infinite possibility. To others it is terrifying. A reality where every tragedy, every loss, every nightmare plays out somewhere. But perhaps that is the cost of infinity, to contain everything, both beautiful and unbearable. The many worlds interpretation remains one of the most debated ideas in physics. It has no experiment yet that can prove it directly, and yet it fits perfectly within the framework of quantum mechanics. It demands no collapse, no special observer, no hidden rules, only that we accept what the equations tell us. Reality is not singular. It is plural. It is infinite. Every moment is a quantum split. Every observation, a creation. Every instant, a new universe, blossoming silently from the wave function of existence. And though we may never cross from one branch to another, the knowledge that they exist changes how we see ourselves. It suggests that our reality, the one we live and breathe, is not the totality of all that is, but merely one leaf on an endless. The quantum leap to other worlds is not a journey through space. It is a journey through possibility itself. A realization that the cosmos is not fixed, but fluid. Not singular, but endlessly unfolding. Not one world, but many, each as real as this one, each echoing the dance of particles that created it. In this branching, infinite structure of existence, we find both wonder and humility. For the universe does not revolve around our choices, it blossoms with them. We are not the authors of reality. We are its participants, its witnesses, its living expressions. The story of quantum mechanics is not only about the tiniest particles. It is about the vastness of what those particles imply. That every moment, every breath, every flicker of chance could be part of an infinite expansion of worlds. All real, all existing, all part of one grand, unfathomable moment. And as we continue deeper into this cosmic mystery, we will ask, can these parallel worlds ever leave a trace? Can we ever glimpse them or feel their presence? Could there be evidence, however faint, that other realities touch ours? In the next chapter, we step from the conceptual to the mathematical, from theory to evidence, to the hints buried in equations and in the cosmos itself, the faint whispers that may reveal that our world is not alone. Chapter 3. Evidence in the equations. For centuries we have relied on observation to reveal the truths of our universe. We build telescopes to peer into the distant past, particle accelerators to probe the smallest realms, and equations to describe everything in between. But when it comes to parallel dimensions, to other universes beyond our reach, we find ourselves in a strange position. We cannot see them. We cannot touch them. Yet their existence may be written in the very mathematics that governs our world. The quest for evidence begins not with a telescope, but with the laws of nature themselves. Because if multiple universes exist, they must obey the same underlying logic that our own does. And within that logic, there may be clues. The equations of quantum mechanics are astonishingly precise. They predict outcomes with accuracy so extreme that to disagree with them, even slightly, would mean denying everything from the functioning of your smartphone to the glow of the stars. These equations describe how every particle evolves as a wave function, a mathematical object that encodes all possible states of that particle. When we calculate it, we find that the universe doesn't favor one outcome. It embraces all of them. This already is a form of mathematical evidence for multiple realities. To most interpretations, that superposition collapses into a single result when observed. But in the many worlds interpretation, it doesn't collapse at all. Instead, it unfolds into every possible branch. Each branch becomes its own self-contained reality, governed by the same laws, evolving independently. The math does not end at our observation. It continues, branching infinitely. If this sounds abstract, it's because our minds were never designed to hold infinity. But in the language of equations, infinity is not an exaggeration. It is an inevitability. The great physicist Richard Feynman once said that if you think you understand quantum mechanics, you don't understand quantum mechanics. And yet he also showed that to predict the motion of a single particle, we must consider not just one path through space, but every possible path it could take. Each one contributes to the total reality we experience. In a sense, the particle explores every possibility, and our universe emerges as the sum of them all. But what if those paths don't merely contribute? What if each one is real? What if each possible history exists in its own distinct universe, just as valid as ours? In Feynman's path integral formulation, the mathematics doesn't forbid it. In fact, it seems to demand it. Still, for evidence, mathematics must meet observation. So physicists turn their gaze outward, to the vastness of the cosmos. Our universe began with the Big Bang, a moment of unimaginable density and energy, when space itself erupted into being. In that first fraction of a second, it underwent a period called inflation, an exponential expansion that stretched faster than light, smoothing and flattening it. Inflation theory was proposed to explain why the universe looks so uniform in all directions. But as scientists refined the equations, something remarkable appeared. Inflation does not simply happen once. In many versions of the theory, it never truly stops. Instead, it creates bubbles, pockets of space where inflation ends and a universe forms. Each bubble expands, cools, and evolves into its own cosmos, with its own stars, galaxies, and perhaps even life. Meanwhile, inflation continues elsewhere, endlessly, spawning new universes in a chain reaction of creation. This is the concept of eternal inflation, and within it lies a natural explanation for a multiverse. Our universe may simply be one bubble among countless others, each separated by vast, unreachable distances, perhaps obeying slightly different laws of physics. The constants that define our world, the strength of gravity, the mass of the electron, the speed of light, may vary from bubble to bubble. Some may collapse instantly. Others may flourish for billions of years. And in this infinite sea, it would be no surprise that one bubble, ours, just happens to have the right balance for life. This idea, strange as it sounds, is supported by the same equations that describe the very birth of our universe. Inflationary models, quantum field theory, and general relativity all converge toward this cosmic plurality. But the most haunting question remains: if there are other universes, can we ever detect them? Could their presence, however faint, leave fingerprints upon our own cosmos? Perhaps. Physicists have searched for such traces, subtle irregularities, anomalies, tiny imprints on the background radiation that fills all of space. This radiation, the cosmic microwave background, or CMB, is the oldest light in the universe. It is the afterglow of creation, a map of the sky that shows us how the universe looked just 380,000 years after the Big Bang. When we study it, we find an astonishing uniformity, a smooth pattern of heat and cold that stretches across the heavens. But there are also oddities, regions that seem slightly cooler than expected, anomalies that some call cold spots. One of these in particular has drawn attention, a vast, unusually cold region in the CMB, the so-called cold spot. Some have speculated that it could be the scar of a collision between our universe and another bubble, a faint bruise on the skin of the cosmos. Others argue it is simply a statistical fluke, a product of cosmic variance. Yet the idea lingers because it hints at the possibility that universes may not be entirely isolated, that they might, on rare occasions, brush against one another. Mathematics again points to deeper possibilities. In string theory, the fundamental ingredients of reality are not particles, but tiny vibrating strings, filaments of energy oscillating in multiple dimensions. The vibrations of these strings determine what kind of particle they appear as: a photon, an electron, a quark. But for string theory to be mathematically consistent, it requires extra dimensions, not the familiar 3 of space and 1 of time, but 10 or even 11. These extra dimensions are hidden, curled up so tightly that we cannot perceive them. Yet within these higher dimensional spaces may lie the key to understanding parallel realities. In some versions of string theory, our entire universe is a 3-dimensional brain, a membrane floating in a higher dimensional space known as the bulk. Other brains may exist parallel to ours, each carrying its own universe, each with its own galaxies and laws of physics. Sometimes these brains could even collide, an event that in theory could ignite a Big Bang, giving birth to a new cosmos. This vision, multiple universes as parallel membranes drifting in higher dimensional space, is more than poetic metaphor. It arises from equations that physicists use to unify quantum mechanics and gravity. It is called M-theory, one of the most ambitious frameworks ever conceived. According to M-theory, the multiverse may not be a chaotic explosion of randomness, but a vast geometric structure, a cosmic landscape shaped by the fundamental vibrations of existence. Every stable configuration of these strings and brains corresponds to a possible universe, and the number of such configurations is not small. It is staggering. Some estimates suggest there could be 10,500 possible universes, each with its own consistent set of physical laws, numbers so vast that they make infinity feel tangible. Here, mathematics becomes more than a tool. It becomes revelation. The same equations that describe the particles in your body also whisper of countless worlds you will never see. And while we cannot yet travel between them, we can trace their fingerprints in theory and symmetry in the fabric of possibility itself. Physicists often say that beauty is a clue in science, that the universe at its deepest level tends toward mathematical elegance. The equations that describe parallel universes are not arbitrary. They are the natural extensions of theories that already work. They are not wild imagination. They are what happens when you follow the math wherever it leads. Yet even as theory expands, evidence remains elusive. Every attempt to glimpse beyond our cosmic horizon faces the same problem: the speed of light. We can see only as far as light has had time to travel since the birth of the universe. Beyond that, there may be other universes, but their light will never reach us. They are forever hidden beyond the cosmic curtain. Still, subtle hints continue to appear. Tiny quantum fluctuations imprinted in the CMB, unexplained patterns in cosmic data, potential gravitational signatures that might one day betray the existence of other brains. Each clue, fragile and uncertain, keeps the search alive. Because for many scientists, the evidence is not just in observation, it is in consistency. When every major theory of physics, quantum mechanics, general relativity, string theory, cosmology, points, however faintly, toward multiplicity, it becomes hard to ignore. Perhaps the multiverse is not an exception, but the rule. And yet, there remains something even deeper, something that connects this grand cosmic architecture to the smallest, most personal question of all. What is consciousness? How do we, as observers, fit into this infinite branching of realities? If reality divides with every observation, does our awareness divide as well? Do we, too, exist in countless copies, each living out one thread of the grand design? The search for evidence, it seems, is not only in equations. It is also within us, in the mystery of how our minds perceive one version of reality among infinitely many. In the next chapter, we turn inward, from the vast mathematics of the cosmos to the deep enigma of consciousness and perception. We will explore what it means to exist in one branch among countless others, to experience the unseen dimensions not through instruments or data, but through the fragile, luminous window of human awareness. Chapter 4. Experiencing the Unseen. What does it mean to exist? It's a question as old as thought itself. Yet as quantum physics pulls at the edges of reality, the meaning of that word existence grows stranger with every revelation. For centuries, humanity has sought to understand the world through observation, to measure, to name, to define. But what happens when the act of observing is not passive, when it creates what is seen? At the heart of quantum mechanics lies a paradox that defies intuition, the observer effect. In the quantum realm, the simple act of measuring changes the outcome. Before observation, a particle is not in one place or another. It exists in a state of potential, a ghostly superposition of all possibilities. Only when it is observed does it seem to collapse into a single reality. But what if that collapse is not the destruction of alternatives, but the splitting of them? What if observation does not decide reality, but divides it? You look at a particle. You find it here. But somewhere unseen, another version of you sees it there. Two observers, two results, two realities, both equally real, both equally alive. The quantum world is not a stage upon which events play out. It is a living fabric of probability, where the boundary between what is and what could be is blurred beyond recognition. And yet, we experience only one stream of consciousness. We feel only one path, one unfolding moment. Our senses, evolved to survive, not to comprehend, can only process a fraction of what may truly exist. We are like fish describing the ocean, never realizing the sky above. But what if, in rare moments, we do sense something beyond? A flicker of déjà vu, a sudden recognition of a path not taken, the eerie feeling that we've lived this moment before, or that somewhere something slightly different happened, and yet we remember it. Could these be mere tricks of the brain, or faint echoes from other versions of ourselves, brushing against the thin veils between worlds? Physicists would remind us, Perception is not proof. But philosophers might counter. Experience is all we ever have. The unseen may not only belong to the cosmos, it may dwell within the mind itself. Consciousness remains the deepest mystery of all. Science can describe the firing of neurons, the electrical storms within our skulls, the chemical signatures of thought, but no equation yet explains the feeling of awareness, of I. Some researchers have dared to ask whether consciousness might be entangled with the fabric of reality itself. Could the mind, in some unfathomable way, participate in the branching of worlds? Could our awareness be a traveler perceiving one thread of an infinite cosmic braid? It is here that physics meets philosophy, and science brushes against the boundaries of mystery. The many worlds interpretation tells us that every possibility exists, but not every possibility is felt. We, as observers, ride one wave through a sea of infinite outcomes. We are both the observer and the observed, the dreamer and the dream. Imagine this. You stand before a door. Behind it are countless versions of reality, all waiting, silent, overlapping. When you open the door, one path unfolds before you. But somewhere the others unfold too. You will never know them, yet they exist, as real as the one you call your own. It challenges not only our understanding of matter, but our understanding of the soul. For if there are infinite versions of you, all making different choices, all following different destinies, then who are you, truly? Are you the sum of all possibilities? Or just the story you happen to be aware of right now? Some find comfort in the idea that nothing is ever truly lost, that in some other reality, every dream unfulfilled has found its place. Others find it deeply unsettling that we are fragmented across infinite worlds, endlessly dividing, forever unknowing. Yet perhaps both are true. Perhaps our consciousness does not cling to one timeline, but flows like a current, a pattern that persists even as the universe branches, a melody that continues, changing notes, never ending. Even in philosophy, echoes of this idea have long existed. Ancient mystics spoke of infinite worlds, unseen realms that coexist beside ours. Buddhist thought speaks of the many worlds within the same moment. In Hindu cosmology, universes are born, expand, dissolve, and are reborn again, a cosmic cycle not unlike what modern cosmologists describe as the multiverse. Science, in its own way, has arrived at the same horizon through mathematics rather than meditation. But it is crucial to distinguish between the poetic and the provable. Parallel dimensions in quantum physics are not realms of dreams or divine planes. They are the logical consequence of quantum laws applied universally. Strange, yes, but scientific, not spiritual. Each interpretation attempts to describe the same puzzle. Why do we experience one outcome when reality could allow many? And though the language of spirituality and physics diverges, both share the same heartbeat, the search for what lies beyond the visible. In our daily lives, the unseen surrounds us. Magnetic fields we cannot feel. Dark matter we cannot see. Quantum interactions happening in every atom of our bodies. The boundaries between the seen and unseen are not fixed. They are defined by our instruments, our perception, our understanding. What is invisible today may be obvious tomorrow. So too may it be with the multiverse. Perhaps the dimensions beyond ours are not unreachable, only unrecognized. Perhaps they press against us constantly, like unseen waves against a shoreline. And maybe, just maybe, consciousness itself is the window through which we faintly sense them. When we dream, when we imagine, when we make choices, perhaps these are the faint ripples of countless universes converging. Every thought, every moment of uncertainty might be a whisper from a parallel you, making the same decision differently. You are not a single being. You are an orchestra of possibilities playing in cosmic harmony. And yet, there is something deeply human about the need to feel real. We seek solidity, meaning, coherence. In a universe that may contain infinite versions of us, we cling to the one we can touch, love, remember. Maybe that is the gift and the burden of consciousness, to choose one melody and call it our life. If all realities exist, then every joy, every tragedy, every version of history is happening somewhere. The fall of empires, the birth of stars, the lives unlived, the words unsaid. And yet, here you are, in this version, in this one fragile, irreplaceable thread of reality. Perhaps that is meaning enough. For even if we are infinite, we can only experience the present. This world, this moment, this consciousness, this is where existence meets awareness. This is where the unseen becomes known. And somewhere beyond, unseen, untouchable, but not impossible, the other worlds continue to unfold, each with their own skies, each with their own suns, each with their own you. The unseen is not empty. It is the heartbeat of creation itself, forever echoing through the dimensions, forever reminding us that what we see is only a shadow of what truly is. Chapter 5: The Future of Reality. The deeper we peer into the universe, the more it transforms beneath our gaze. Each new discovery rewrites the story we thought we understood. And now, as the frontier of physics stretches toward the unimaginable, we find ourselves facing not just new questions, but a new kind of reality itself. For centuries, the dream of science has been clarity, to reduce complexity into order, to map the unknown into understanding. Yet, as we approach the quantum horizon, clarity gives way to mystery. The closer we come to understanding everything, the more we realize how little we truly know. The question that once belonged to philosophy, what is real, now belongs to physics. And physics, in its search for truth, is venturing into places that once seemed like pure imagination. The universe we live in may not be the universe at all. It may be a single bubble floating in a sea of countless others, each governed by its own laws, each humming with its own version of existence. Some are cold and lifeless. Some burn with alien suns. Some expand endlessly, while others collapse before a single atom can form. And somewhere among them, there is one that gave birth to you. The multiverse is no longer just an idea whispered in science fiction. It is a possibility emerging from the mathematics of reality itself, from string theory's infinite membranes, to the quantum branching of the many worlds interpretation, to the cosmological inflation that might seed universes like stars in a cosmic ocean. We do not yet know if these other worlds are real, but they may be closer than we imagine. The next century of physics may reveal clues not through telescopes, but through subtle fingerprints hidden in the data, strange alignments in the cosmic microwave background, unexpected patterns in particle behavior, or anomalies in quantum computing that hint at interference between parallel outcomes. Every new experiment, every deeper dive into the quantum realm could bring us closer to the edges of other dimensions. Imagine a future where reality itself becomes a laboratory, where we do not simply study the universe, but learn to navigate its layers, where the boundaries between possible and actual begin to blur, and humanity becomes aware of the infinite stage upon which existence unfolds. Even now, physicists are building tools that may touch the unseen, particle colliders that probe the smallest fragments of creation, quantum computers that mimic the logic of superposition and entanglement, machines that, in their operation, may echo the behavior of parallel realities themselves, and gravitational wave detectors that listen to the ripples of space-time, like cosmic ears pressed against eternity. Perhaps one day these instruments will do more than observe. Perhaps they will confirm that the universe we know is one among many, and that reality is not a solid wall, but a shimmering veil. But what happens when the veil is lifted? When humanity learns, beyond all doubt, that we are not alone, not just in space, but in existence itself? Would we look upon the infinite and feel wonder or fear? Would it make us smaller or greater? Would we find meaning in the knowledge that every version of ourselves, every possible world, exists somewhere beyond our reach? In the grand arc of discovery, every revelation has both expanded and humbled us. We once believed the earth was the center of everything, and learned it was a grain of dust. We believed life was unique to our world, and discovered the universe is filled with planets like ours. Now we may learn that even our universe is just one voice in a cosmic chorus. And yet in each revelation we find not despair, but beauty. For if the universe is infinite, then so too are the possibilities for understanding, for experience, for wonder. The frontier of physics will continue to unfold in silence. Equations scrawled in chalk on blackboards, simulations running in cold data centers, telescopes gazing into the abyss. Somewhere a new theory will be born, one that bridges quantum mechanics and relativity, that unites the small and the vast, that reveals the underlying truth behind all realities. The physicists of tomorrow may not merely describe the multiverse. They may find ways to glimpse it, to feel for the first time the gravitational tug of another world, faint but undeniable. But even as science advances, one truth remains. The mystery of existence is not something to be solved, but something to be experienced. We are part of the universe's unfolding story, conscious matter reflecting upon itself, aware of its own being. We are the universe asking its own name. And as we ask, reality deepens. Perhaps the greatest discovery will not be out there, but within, in the realization that the boundaries between worlds may be as fluid as the boundaries between thought and matter, between dream and waking, between imagination and truth. We are the witnesses of creation, the storytellers of infinity. And as we reach further into the quantum fabric, we begin to sense that we are not separate from it. We are it. Each particle in our body, each neuron that fires, each choice that shapes our lives, all are quantum events. Each may echo into universes unseen. Somewhere, another version of you listens to this very thought. Another wonders the same questions. Another makes a different choice, and the story diverges. And yet, in some strange and perfect symmetry, all of them are you. Every version, every possibility, all woven together into the infinite pattern we call existence. When we speak of the future of reality, we are really speaking of the future of understanding, of how far human curiosity can reach before language itself falls silent. We may never hold the multiverse in our hands, but in our minds we can grasp its shape. We can imagine, dream, calculate, and explore, until imagination and observation become one. The next great revolutions may come not from breaking atoms, but from expanding perception, from learning to see reality not as a line, but as a web, from recognizing that everything from galaxies to thoughts is connected through an invisible symmetry that stretches across dimensions. Perhaps someday humanity will no longer speak of other universes. We will simply speak of the multiverse, as naturally as we once spoke of the heavens. And our descendants will look back not at myths or stories, but at us, the generation who first dared to ask, what lies beyond? The future of reality is unwritten. It waits in the equations not yet solved, in the instruments not yet built, in the minds not yet born. It waits in the dark, patient, silent, infinite. And as we continue to seek, to question, to dream, we participate in the act of creation itself. We are not just observers of the cosmos, we are part of its self-discovery. The universe is learning about itself through us. So perhaps, after all, there are no separate worlds. Perhaps every dimension, every branch, every echo is simply one vast consciousness, the cosmos awakening to its own existence. Every world is a thought, every thought a world. And in that realization, everything changes. The boundaries between physics and philosophy dissolve. The division between science and spirit blurs. All becomes one vast continuum of being. The question is no longer, do parallel worlds exist? But rather, what part of you is living in them now? Because the story of the multiverse is not just the story of other realities. It is the story of reality itself, infinite, eternal, and forever becoming. And perhaps in the quiet spaces between universes and the silence beyond time, all the versions of you, all the choices, all the lives, come together once more as one. One consciousness, one existence, one universe dreaming itself into infinity.